Ladies and gentlemen, welcome at the Tech Lab on this third day of the INCYBER Forum 2025. Now we have the pleasure to welcome on stage Mr. Amir Shamir and Mr. Muhammad Hashim. Good morning, sir. Good afternoon. We are going to talk about hacking the sky, exploring satellites' vulnerabilities, and cyber threats. We're going to have 30 minutes talk, and after we're going to have a questions and answer session. Enjoy your conference, and see you just after it.
Hello, everyone. Thank you so much for having us today. This is probably the last and final session of mine in this conference, and I wanted to make it interesting for all of you. Today we're going to talk about satellite hacking and using trivial and simple methods to exploit vulnerabilities in satellite systems, both on and off radios, analogs, and digital signals. I am Muhammad Shamir, and with me today is Muhammad Hashim. We are cybersecurity researchers in the field, and we work for a company called Vilix. So this has been a very good event so forth. We have been talking about multiple aspects of AI, zero trust, and all these sorts of things. But today, the agenda is to understand how satellites work. Whoops. Agenda. Sorry about that. So yeah, today we're going to talk about how satellites work, satellite hacking and their threats, how we can use OSINT to determine the positioning of satellites, how we can get live images from satellites. We're going to look at the Starlink case study that we have worked on very recently. We're also going to listen to some conversations from the International Space Station, which is a covert channel. And you know, this is the agenda for today that we'll try our best and most to cover. And believe it or not, to experience satellite hacking, you don't need to have fancy equipment. As an enthusiast, you can just have very simple equipment like a handheld radio, a simple software-defined radio, and a whip antenna. Collectively, these don't cost more than $100, and they can allow you to exploit and listen to satellites and their consequent vulnerabilities. Our engineering background kicks in here, and we were able to very covertly and successfully identify how we can listen to covert and secret communication, how we can listen to satellite communication, and intercept those signals in between. Okay, so a satellite is basically a device that is orbiting a celestial body. Moon is a natural satellite that we have, but there has some point in time, someone actually identified that ground-to-ground communication was not enough. It costed a lot of money. It was not very useful. It was not very efficient. Thus, the particular method of bouncing signals off from something that is in the sky was actually developed. And that's how satellites came into being. There have been multiple satellites. Thousands of satellites are orbiting Earth right now at this very moment, and we have been able to harness their power to make our communication more efficient. Satellites work very, very easily. Like, there's no rocket science to it. The method is there's a ground station, there's a satellite, and there's an uplink and downlink. So what you have in front of you is a station that is transferring signals to something in the sky, and then that signal is being collected and bounced back to somewhere else on Earth. This is efficient communication. These are analog signals that are just bounced from one location or one place to another. So satellites normally work on something called the L band. We have 1 to 2 gigahertz. This is where our global positioning satellites work. Then we have the C band, which is in 4 to 8 gigahertz, the X band, which is in 8 to 12 gigahertz, the KU band, the KA band. We need to understand this because we need to tune our radios to it. Now, why are they vulnerable? The point is that just like any other nascent technology, we think that they're not vulnerable, but they actually, in reality, they are. The isolation of satellites in orbit and their reliance on the wireless communication exposes them to specific vulnerabilities. So from disguising communication from a specific source or a known source or a trusted source, the problem is that we only developed this technology for communication purposes. There was no intent of security when it came to satellite communication. And hence, we have the segmentation of how satellite communications work. We have the space segment, which is in space. We have the user segment, which is the end user itself. We have the link segment, which is the linkage between the satellites and the ground stations. And then we have the ground segment, which is the ground station itself. Now, if you look at it from a perspective of the threat model of these satellites, all of these are divided into these vulnerabilities. For the space segment, we have the onboard vulnerabilities. For the user segment, we have the denial of service or the interruption of services. For the link segment, we have the upload and download problems. And for the ground segment, that basically connects everything. If that particular system is compromised, then the entire system itself is compromised. We're going to look at it. We're going to look at a couple of satellite attack vectors. Jamming is one of them. Eavesdropping is another. Hijacking is another, and control is another. To identify the positioning of a satellite, we need to have certain identification mechanisms. There's the international designation, which is the ID, and there's the NORAD ID. For instance, what you see in front of you is the ID and the NORAD ID. The international designation is basically the year the satellite was launched, along with a code, and then we have the NORAD ID that NORAD actually gives every satellite. So what can you gain from this? We can basically find out the orientation of the satellite, the velocity, and all of its upcoming passes. Now, for demonstration purposes,
to track down a satellite, simply visit n2io.com. Then,
what we're looking at right here is tracking a Starlink 31046 satellite. We know the NORAD ID of the satellite and the international designator of that particular satellite. And what we're going to do is we're going to simply use ny20.com, which is an open source, easily available tool. We are going to enter that information, and we will get exactly everything that the satellite actually has in its lifespan, where it is going to pass, where its orientation is going to be. And this is, believe me, this is public information for some reason, which it should not be. Satellites are not airplanes. They should not have this information on the public internet. So, and as you can see, that what we have in front of us right now is basically all of the information that we can gain from a satellite, including the two-line element set. Now, this is very important. The two-line element set is basically a set of numbers that you can input into multiple equations and, go ahead and identify how those satellites actually work. This is the two-line element set. And why this is important is because if you put this information in an algorithm, it is going to spit out all of the information that a satellite will have in its entire lifespan. The upper numbers contain the name of the satellite, the ID, the epoch, the epigee. These are, non-relevant terms, and terms that normally don't come up when we're talking about normal satellites. Just a second, guys. Okay. Okay, so this is something called orbitalmechanics.com. Now, what we're going to do is, you can't see it, can you? नहीं चल रहा. No, it's not. No, it's not. Okay, yeah, so this is orbitalmechanics.com. Now, what we do is, in this particular, I don't know why the video is being played, but what we do is we input the values of the two-line element set into this particular website, and what it does is it gives us the entire orbit in that particular satellite's lifespan. And that's just it. There is no rocket science to it, or there is no you don't need anything else to basically find out the positioning of that satellite. Now, why is this important? Because that satellite at some point in time is going to pass over your house. And the easiest possible way to intercept the communication or to listen to that satellite's communication is to go on the roof, pick up a radio, intercept those signals, and then comes the decoding part, which is next. Okay. Similarly, we have a tool called SatIntel. Is the video playing? SatIntel basically does the same thing for us. You input different values, just as I said. You input the NORAD ID. You input all of the values that you harvest from the two-line element set. You give it the latitude and longitude of what, when you want to know when that satellite will be above that premises. You give it a certain altitude, and it gives you all of that information, which you can use to essentially carry out your attacks on that satellite. Because analog communication is a bidirectional two-way communication that gives you the ability to hack into any satellite using analog signals. And the easiest hack that you can perform is communication jamming. So getting live images from a satellite, we have Google Earth, which is public information. We have Sentinel Hub, which is also public information. But these are all, you can't get real-time images from these, right? You can't get images that you would normally get from a live satellite. So we have multiple methods for that. And this is how you get live images from a satellite. These are images. You first need to identify the name of the satellite. Then you need to put it into the ny20.com. Then you need to identify where that satellite is going to be at a certain point in time. What's important right here is the latitude, longitude, and the altitude, because the satellite is only going to be visible is only going to be in reach to you at a certain point in time. So we need to have a very accurate information, and then we will be able to intercept or harvest those images. Like, as I said here, those are the longitudes and latitudes that the satellite is going to be visible at, and this is the start and end time of that particular satellite. And what happens then? You just find out how you are going to carry out your next attack, because this particular uplink and downlink actually tells you the frequency of which you can listen to. And very simply, even if you don't have a phone, we were discussing it with someone actually last night, and he told me, can you intercept satellite communications if you don't have a laptop? I said, yes, we can. You just need a simple Baofeng radio. You need this application, which is Wave Editor. And what you're going to do is you're going to go onto your roof. You're going to put the antenna on a certain frequency. You're going to copy that wave file, and you're going to put it into this website that is visible here, penweather.community. And once you do that, it will give you a live feed of what that satellite is actually, viewing right now. So imagine if you live near Area 51, within 10 miles, you could literally see what the satellite is seeing from above Area 51. Similarly, we have something called, we have another demonstration here. It is similarly for ny20.com, and what we're going to do is we're going to use a computer in order to identify the positioning of that satellite. And once we do that, we will be able to harvest all of the images that the satellite is seeing in live. So this is an RTL SDR that we are using, the software-defined radio. The little peak that you see is basically the data that we are getting from the satellite live. And using this data, we will be successfully able to decode it into an image, and that image will be viewed from the naked eye. So as you can see here, we have the software-defined radio with us, and we are intercepting and harvesting communications. We have recorded the audio files, and now what we're going to do is we're going to convert those audio files from something called SatDump, which is another open source and easily available tool. What I do in my sessions is I try to make it as simple as possible for people to understand, so that it's not very complicated. And then you just upload it, set the right bit rate, because every wave, every analog wave is in some spectrum of gigahertz or megahertz, and it is some sort of sound that the computer actually understands. So you're going to upload the wave file and audio file, and it's going to spit out the image that the satellite is seeing. Very shortly. See, that's a live image. That's actually a live image. I know it's blurry and clear because of the unclear because of the clouds, but this is a live image, and if you play around with it, Photoshop it a little bit, you can get very high resolution. In my research, I found out you can get resolution of up to 8K, which you can zoom in and look above people's roofs. So that's a privacy concern right there. And this is another method where you can, in real time, decode a satellite image. Like on the right side, you have an RTL SDR, and on the left side, you are decoding the satellite images in real time. And this is very simple engineering and very simple hacking. I know, but if you buy this from Amazon, you can literally learn all of this in less than a week. So this is how you play around with technology, and this is how you hack technology. So next one. Okay, turn on the volume, please. Now this is another scenario where we are going to use a simple software-defined radio to receive pictures from the International Space Station, which we did because next, we will also try to hear what the astronauts are talking to each other from the International Space Station. Okay, next, please. Right. Now, this is another very interesting demo. This is Google Earth. Google Earth actually allows you to go back in time. But the problem is that there are very sensitive objects scattered around the globe. Chalo. Sorry. So there are very sensitive objects that are scattered around the globe that, should not be there. Google Earth can actually be used to trace and track military aircraft carriers in my area of research. Is it playing? No, it's not. Not playing for us either. Hold on. Tell me. Okay, so yeah, now it's working. So what you can do is, what we did was we were very nifty enough and sneaky enough to find out that there was a military aircraft carrier that was actually located somewhere in Knoxville. And as you can see that, these are objects that should not be visible to the general public. I mean, the people who live nearby can literally go outside, take pictures of these very sensitive objects. Believe it or not, you can view this in 3D. You can find out, the type of equipment, the type of antennas, the type of radios that are being used. And if there are some, fighter jet planes, you can find out the quantity of those jet planes. And you can actually also see when that aircraft carrier arrived at this particular station, and then when that aircraft carrier left the station. So this is actually being viewed in 3D. Google Earth is, we all know and we all love it for whatever reasons, but these are the things that should never be in this particular space. So you can do that using Google Earth. And then you can go, let's talk about hacking Starlink. A Starlink system consists of 3 distinct parts. There is the satellites that are 340 miles up in the air. We have the gateway stations and the dishy McFlat face. Now, a researcher basically identified that you can actually perform something called fault injection into a Starlink terminal, which is basically testing for different voltages and different currents. And what you can do is you can perform fault injection and perform a reverse shell connection with this particular Starlink satellite. It is relatively easy to learn what fault injection is if you're from an engineering background. The researchers were able to bypass. The researchers were able to basically bypass the security protections of that satellite dish using the fault injection technology and access the device's software. To perform fault injection attack, you just simply need a voltmeter and an ammeter, and you can connect it to the terminals and you can go into the bootloader. The consequences of that is you can get free internet, free coverage in areas that Starlink is not allowing coverage at, and you can basically connect back to the satellite itself.
Using just $25 in off-the-shelf hardware, he was able to gain root access to a terminal, allowing him to explore the wider Starlink network, a capability which could enable exploitation of Starlink satellites themselves. So Starlink terminals are pretty locked down bits of kit. There's no way to run custom code on them in the form of plugins or apps. These things run firmware signed by Starlink, and that's it. This forced the Belgian security researcher behind the hack, one Lennart Wouters, hope I got that right, to be creative. After disassembling his terminal, or as SpaceX calls them, Dishy McFlatface, he opted to use a voltage fault injection attack, otherwise known as glitching, in an attempt to load modified firmware, enabling full access to the dish. This attack method, glitching, isn't new. It's the same technique that was used to hack AirTags, turning them into Rick-roll tags. Glitching works by interrupting the power supply to the dish's CPU for a very short period of time in order to skip certain processor instructions. The aim here is to skip the secure boot code, which verifies that the firmware stored on the memory chip is signed by SpaceX and hasn't been tampered with. Glitching isn't straightforward.
So that's just basically it. Okay, now we're gonna go for some satellite hacking and listen to some people that are already talking on these satellites. We just need a 1 meter VSAT terminal. We can access a satellite that is more than 25,000 miles away in space, and we can make free phone calls. Listening to the ISS. Now, the ISS has dedicated websites where you can listen to communications, but they are very restricted. They don't allow you to listen to classified information. But what if we want to access that classified information? What do we do? Now, these are astronauts talking. I'm going to keep quiet so you can listen.
Roger, roger. Thank you. Have a good evening there. WA0D.
Now, that's better than Skype, I assume. The audio quality is better than Skype and Zoom. You're listening to astronauts who are wishing each other good evening. They may be transferring some sensitive data between their communications. And what's happening here is we just have a radio in our hand, and we're not even on our roof. And we can easily do that. Let's go forward, guys. Let's see what we... That's the space station.
Kilo Oscar 4, Mike Echo Mike. This is Whiskey Charlie Papa Tango, Echo November 82, QSL.
Now that was the International Space Station. This again is the International Space Station, but with a better radio.
Whiskey, VK5 Echo uniform. You're fine there, Graham. VK5EW, VK3 triple W. And also 5 and 9, name here is Jack, Juliet Alpha Charlie Kilo, over. So, missed any of the comments you made. But anyway, good to hook up with VK3 triple W, VK5 Echo uniform. Uniform, okay. No worries there, Graham. You're good 5 and 9, no problems at all. VK3 triple W.
We can take it another step further. We can put a radio in our car and literally follow the space station around the country to basically intercept those waves. This is a Kenwood radio, I believe. The quality is not very optimistic, but it works on the same principle. And then hold on. And then it works both ways actually. You can listen, and then you can transmit on those frequencies to talk to those astronauts, to talk to those pilots. Now, imagine if the Crew 9 thing that recently happened, imagine if they were given wrong coordinates by a malicious attacker out there who was just sniffing and doing a man-in-the-middle attack. How would that have been done? And I think we're out of time. Okay. I think I'll end it with this. This is something called space pirates. When Russia and the US were experimenting with satellites, they basically put out a lot of satellites in space and then decommissioned them. By decommissioned, I mean that those satellites were never actual, there was no way to turn them off. So what happens is that malicious actors, drug dealers, smugglers, and these kinds of, sneaky people, what they do is they use these satellites as a form of communication and covert channels. And this is a decommissioned satellite that was launched back in the 70s for basic radio communication. And this particular demonstration, what's happening here is you're listening to, some kind of malicious actors talking to each other.
Hopefully no.
Let's look at it again, sorry. Okay, we had a couple of more demos where we were able to transmit data back to a naval satellite, and we hunted for decommissioned Navy satellites, but I'm told we are out of time. So if there are any questions, please, I'm happy to answer them.
Ladies and gentlemen, please give a round of applause for our two speakers here, Muhammad Hashim and Amir Shamir, hacking SpaceX on a $25 budget, talking and receiving ISS communications with a simple radio device. That's how we can jam the system and hack every organization that are as big as this with just knowledge and simple material. If you want to have some other discussions, if you want to go deeper into the subject, don't hesitate to reach Amir Shamir here next to the stage. They're going to be here for a moment to discuss about what we have told here. There are also the possibilities to catch up the conference from today as well as the conferences from yesterday and 2 days ago, because in a month or so, they are going to be uploaded on the YouTube channel of INCYBER Forum, so you can catch what have been talked about today. Thank you very much for your presence, dear audience, and we are going to be back in some kind of 5 minutes time to have our last convention here, our last speakers on stage. Thank you very much, have a nice INCYBER Forum, and thank you for your attendance at the Tech Lab.